All right, so after that intro about data visualization, let's take a look at what we can and cannot do in Python. Today we just talk about the fundamentals. How can you actually plot simple functions the same way you do in other softwares or software packages. Then we'll go into more specifics in the next class about how can you use pandas and the other library called Seaborn to plot more fancy plots. They both are built on the same package or library we're going to talk about today, but they're more, it's easier to deal with data when you use Seaborn and pandas, right? Matplotlib is easier to use when we're just plotting things, functions. For data, it's okay, it can be used, but pandas and Seaborn libraries are easier to use, and they're specifically designed to plot data sets and different things in the data. But we need to know the fundamentals about Matplotlib, and then we'll refer to these again and again and again. A lot of these features are there because they are, again, built on Matplotlib. Now, okay, hopefully you have the notebook open, you follow. Some introduction I put there. As I said, we can make plots. One of the great features of Python compared to other programming languages is that, and that's why it's, not why, but one of the main reasons it's very popular in data analysis is because it gives you a great power in terms of data visualization. And, we get the data, you can plot it, you can deal with big data sets. You don't have that luxury, obviously, when you're using C++. C++ is faster, but then you don't have such great fancy tools that you have in Python, especially when it comes to data visualization. Now, put here, we're going to be mainly focused, especially today, on Matplotlib library and the other library that is built on Matplotlib, which is called Seaborn. I'm going to talk about Seaborn and pandas, how to use those for plotting. Obviously, pandas is for data analysis, you remember, but it has some like built-in functions for plotting directly without calling Matplotlib library or Seaborn. Seaborn is also pretty good. It's relatively new, of course. It's built on Matplotlib. And there is another library that we'll talk about in this, not next week, the week after, and it's called Plotly. Plotly is more advanced. It creates more fancy, I would say, interactive plots, you'll see. And for just plotting the maps, I'll give you another way of plotting maps, like geographical maps, how to make interactive maps. And that's, again, is for a week after next week. Matplotlib is a plotting package, mostly for two-dimensional data. You'll see, and as I said before, in the first half of the class, in data analysis, we barely use with three-dimensional, we barely deal with three-dimensional plots. Find other ways. Either we represent data's different features in separate 2D plots instead of putting them in one 3D plot, or find other ways to reduce the dimensionality of the data set so we can actually represent it in lower dimensional space. But two-dimensional plots are very common, and that's what we use. I'll talk about three-dimensional a little bit, but we're not going to be focused on that. Let's just learn the fundamentals, as I said here, about Matplotlib. You see even the name kind of insinuates that it has a lot in common with MATLAB, the way we plot functions in MATLAB. So you are going to be the judge of that, how close it is. I'm going to run the first cell to import Matplotlib library, and I'm also importing NumPy as NP. So to import Matplotlib, I'm specifically importing PyPlot module within Matplotlib. So I'm importing matplotlib.pyplot. Like Matplotlib is a library, PyPlot is a module within that library. I'm importing that, whatever function, because we are going to use functions within PyPlot. Matplotlib is a general library. As PLT, right? We said when we say as something, it means import that with this name. And I imported NumPy as NP. I put two options here. We are, at least I am using, and most of you are using Google Colab, right? This on the cloud service to run our Python code. Now, on Google Colab, you can't get a plot that is interactive, or better to say, a plot that opens up in a separate window, and you can do a few things with it, save it, change the labels, because it's a cloud-based service. But if you have it, you're running it on your own computer, you have two options. You can put Matplotlib inline, which means that you are going to have all the plots that you have within your notebook. Like, we'll see what I mean. Or you can use Matplotlib Qt, which switches that to getting the plots out of your notebook and having it as a separate window. Now, there are benefits to, I guess, to get them outside of the notebook, but the common practice in data science and data analysis is that to have it inside your notebook. So a lot of time when I start writing a code and I import the pyplot or Matplotlib pyplot as PLT, I also activate this comment and I put Matplotlib, exactly like that, inline. Meaning that I want all my plots to be within my notebook. I don't want a separate window, because a lot of time we just submit that notebook as the final report. So we want all the plots to be there. In this case, we don't need to use Matplotlib inline, but if you're running it on your computer to be consistent and get what I get, you have to activate this comment and put Matplotlib inline. Let's start. So first step, we have to, so a figure is an object in Python. So first we have to define that object. So we have to create a new figure, an empty figure, and then populate that figure or object with the plot that we want. So most common way is to do it, well, I guess the only way is to do it as far as I know, is to use plt.figure, right? Within plt, the function figure, and then within this function figure, I put an option. Right? I put the most common option that you use a lot when you define a figure. Think about it. You're defining just an empty frame for now. I will say define a figure, right? Object, plt.figure. And for that figure, make it, the size of the figure, make it 10 by 4. So the width, I want to be 10 inches. And the height, I want to be 5 inches. Right? Now, it's an empty plot. Nothing happens there. I'm putting it in fig. You may or may not put that. It's more advanced. There are more advanced way of plotting. This is one way of plotting functions and plots using Matplotlib. There are multiple ways of doing it. Right? I'll give you the most straightforward methods, but there are multiple ways depending on the preference of the programmer who's dealing with the code. So I put it in an object called, I called it fig. You could call it whatever you want. So running the first line is going to create an empty frame, 10 inches width, 5 inches height. Now I defined, hopefully you remember this from NumPy, I used linspace. I said if within NumPy, use the function linspace and create a vector from 0 to 2 pi. Keep in mind, to define pi is a number defined within NumPy. So I put np.pi. And divide that interval from 0 to 2 pi to 50 samples. So it creates a vector from 0 to 2 pi, and I'm going to have 50 samples there. And then using that vector, feed that vector into sine x. So I get the y value would be the sine of that whatever range I have. Calculate the sine function from 0 to 2 pi in 50 points. Pretty much that's what these two lines do. To plot, I have that empty frame. Now within that empty frame, I can plot what I want. I say plt, pyplot function from Matplotlib that I imported as plt, dot, right, function within that, attribute within that, the function within PLT is easier to say, plot x and y. If I run this, I get a 10 by 5 plot. Sine function is plotted from 0 to 2 pi. Right? That's pretty much the basic that you do for most of the plots you plot with Matplotlib. Right? Define the figure object, give the size, define whatever function you want to plot, and then you say plot x and y. X being the x-axis, y being the y-axis. Whatever you put here doesn't have to be x and y. It can be t and f. Whatever you define your vector and the function operating on that vector. Now, obviously, this is just a very simple plot. We have to look at different features and functions. We have to manipulate this plot the way we want. I made it a little more advanced. I said, well, I want to customize this plot. So let's just start with where I started. Right? I started with, again, I want to make a plot. So PLT figure, and the size of the figure, again, 10 by 5. Now I still have X, Y from before, right? I ran the previous cell, so X and Y are already defined in my notebook's memory, the 2 variables. Now I put some options. Right? I said I want the color of my plot to be green. I want to use a marker, this type of marker, to represent the exact data point that you calculated the function. I want the line style to be dashed line. I want the thickness of the line to be 2, and the marker size, which I'm talking about this marker here, to be 12. Obviously, by increasing them, you're going to have a thicker line and bigger markers. If I just run this, I'll get a plot, same size figure. Now these markers are there. They are green, and I have a dash line. You can't see the dash line very well because the data points are too many. Dash line is connecting these data points. The line thickness is 2 and marker size is 12. So I can decrease the marker size, let's say to 8. Right now it's a smaller. I can even get a smaller one by, let's make it very small, like 2. Very small, you barely see it on the dash line. I can make the line thicker, depending on, again, the preference, the type of plot you want to make and what you want to represent. Or what you want to be more bold in your plot. Now let's take a look at these lines one by one. First one, PLT, again, is a function from Matplotlib. .grid creates a grid. There are possible options. I encourage you to take a look at PLT grid, question mark, create a new cell and take a look at options. Common one is B equals to true, meaning that make a grid. Right? So now it has a grid. Next line, 2 lines, I'm giving limits. I'm saying plt.xlim, meaning the limit in x-axis. I want the limit to be from 0. Look at how I define the limit, right? I'm going to make a space here so it's more clear. That I put the limit in a set. 2 elements. First one is the beginning of the plot in x-axis. The second one is the end of the plot on x-axis. And I said, I want x-axis to be limited from 0 to 1.9 pi multiplied by pi. Y-axis, the same story, a list from minus 1.5 to 1.5. So I'm defining the limits for x and y-axis. So if I run that, now you see the limit changes from 0 to wherever 1.9 pi is, and the y-axis limits. The limit changes from minus 1.5 to 1. Adding more features, I am defining the labels. I say plt.x label, the label for x-axis. I went with some random name x values. And label for y-axis, I put amplitude. Keep in mind, these are strings, right? It's a specific name I'm putting. So it's a string variable. I put it in quotation. Could be single quotation, double quotation. So now I have a plot. It has labels, x values for x, amplitude for y. Finally, I can put a title, PLT title. Again, it's a string, it's a name. You just put sign function. So I put it within the string, within quotation. If I run it again, now I have a function, a plot that is 10 by 5, is green. It has markers, the line style is dashed, the line width is 2, marker size is 8, and with all these features, the grid, I gave x limits, y limits, x and y labels, and the title. So it's much better than what we had, the naked plot we had from before. Right? It defines some features. Now, you might ask that, well, how did you know you should put green here as green, or marker, this is the sign for marker. How did you know this is an option for line style? I put a link there, Matplotlib pyplot.plot. You can click on it, scroll down all the way. It gives you a pretty much thorough list of options. Markers, the possible options, right? I used a circle marker. You could use any type of marker you want from here, right? Star marker, diamond shape marker. Just make sure that you put the corresponding option. Here I just put this one. To get a circle marker, I could put whatever I want from this list. The second table gives you the line style. I put dash line, and that's pretty much, I wrote dash. What I could do is I could just do this instead. If I do that, I'll get the same thing. Well, the markers are too big to make it smaller. I get the same thing. So these are the options. If you don't want dash line and you want solid line is a default. If I don't define it, it's going to be a solid line. But if you want to define it, just use one. It's going to give you a solid line. Other options, you want a dash dot line, you know, you pretty much just add a dot next to it, then you're going to get a dash dot line. So these options are here. You don't need to memorize that. Colors, I put green. I wrote green, but I could just put G. Right? It's a more common way. I could just put G, saying that I want this to be green. Go there. These are the typical colors you can use without even getting into the nitty-gritty of defining the color using different methods. There is an option how to define a color. If the color is you want to be more specific, take a look at the link. You can actually use a string value. These are different hex way of representing a color. You can look at it. These numbers you can look up on the internet and use these numbers directly to get a specific color that is not in this list. I could use just a black color. You can just change this to K. Right? Gives me a line with black color. And none of these options are mandatory, as you saw before. I can just get rid of all of these and just plot X and Y, and it still gives me a plot. These are options to customize the plot. All right. I also put it here. You could put all of them in one option, in one quotation. So instead of making it, oh, I want a marker. Let me see if I can keep both in the same place. I want it to be marker, the line style to be dash line, for instance, and the color be black or green. You could just remove all these three and say, I want it to be black, I want it to be a dash dot line, and I want the markers to be circle. It still gives you the same thing. You change the marker size to 5, so I just see what is going on. It's more abbreviated, it's a short version. You're comfortable with that, do it instead of setting them separately. I just set them separately so it's clear that what everything is. But you can just put them all together, the color, the line style, and the marker. And doesn't all of them have to be there? Just one of them two of them is there, so then it's going to be a default line. It's going to be a line with no markers, black, and it's dash dot line. List of possible markers. I think, I don't know why I repeated the same link, but it's the same link I opened here. So you can see the list of possible markers, colors, and line styles. Now here is what I want you to do. I want you to plot a function for your practice. Keep in mind, when I say function, now in this case, what you're going to do, you're going to go back to what you learned from NumPy. Right? Instead of NP sign that I use, now you have to define it as a polynomial. How did we define things in polynomial? You define t, let's say, as np linspace, np.linspace. I then define the vector 0 to 3, get the number of points that is good for this representation. And then you can define your function, right, as a function as a polynomial. Right? Whatever t is, then you can just easily say 5 times t to 3. Right? Remember, 2 multiplication sign or 2 star was the sign you were using to find the to raise the variable to a power. Right? This is element-wise raising to a power. Right? And the same thing you can do minus 15 times t squared, and go on. You define the variable, define this function as y, and then plot t and y. And these are the few things I ask you to do. Make sure the figure has the size is 12-inch width. Its width is 12 inches and its height is 6 inches. title the plot. I give a suggestion, function of time as a title with X and Y axes labeled as time, second. These are axes that you have to define, displacement. And do not use any marker, and plot the function using dash dot line with a thickness 5. Right? And I want you to use a color black for a plot, and also turn the grid on. So one thing I wanted to show you is what I was talking about at the beginning. Right? When I said Matplotlib inline and Matplotlib Qt, right? When you're running it on your own computer and you're within notebook environment, right? This is my computer. I opened the notebook, Jupyter notebook, very similar to notebook you get on Google Colab. If you install Anaconda, and one of the options you get is to run Jupyter notebook, and it opens a very similar environment in your browser. Now, I defined this tool, I plotted some random sign, the same sign function. Right? Now, by default, mine is on inline. Right? If I activate this or don't activate this, it doesn't really matter. Okay, there you go. And then obviously it's inline, it's within the notebook. Now, if I change this to this one, I say Matplotlib Qt, now run this, if it doesn't disappoint, and it follows. If I run this now, you will see nothing shows up in my notebook. I have it down on my taskbar, I have it. So if I click on it, this shows up. Now it's more interactive. You can save it. I'll tell you how to save a figure when it's within the notebook. You can edit axes similar to what, relative to what you can do, the x-axis, the limitations we can set here. You can set the label for x. You want it to be even some manipulation. It's going to be logarithmic or linear. You can y-axis, you can give limits and label. By the curve, you can put the label, what kind of line do you want, the same options you had before. Width of this line, the color, right here you can just directly change the color. You know, marker right now is nothing. You can change it to whatever you want. The size of the marker, the color of, so you can decide about two things about the color. I didn't talk about it there. You can decide about the face and the edge. Right? The colors can have different the markers. Right? If I click on that, you see now markers are there. They have the color red for their edges, and they have color, whatever this color is, as their face. And you know, we can just pan it around, move it around. You can zoom in a specific area, go back to where it was, like we set to home view. So this gives you, you know, more interactive, I would say, version of the plot. If you have multiple lines, multiple plots, I'll talk about it. Here you're going to have multiple options. You can label them and put the legend there. And you can save it, obviously. You can save it as a PNG file, EPS file, depending on vector file, SVG. So this is the difference. Right? If I change this back to what it was, Matplot inline, again, just a comparison, you just get your plot within your notebook. So this option is not available when you're working on a cloud. That's what I wanted to tell you about the difference between these two. All right. Now you can change the style. Right? That's one of the fancy thing about Matplotlib, is that you can change the style with which you plot your graph. So there is a list of styles, like there's a gallery that gives you a list of style, BMH, the classic style, some examples, like dark background, 538 style, GG plot, which is very similar to the plots we get in R environment. Grayscale, Seaborn, Bright, you know, I'll talk about Seaborn library, but you can get the same style in using Matplotlib. And the list of different styles here, you can choose any of these. You want to get the list of these, I put the command here, plt.style.available. It gives you a list of all the available styles. You can play around with it and see which style you like or fits whatever you're trying to present. I just put an example. I said, well, set this style on dark background, and I got it from here. Pretty much just copy and paste it from there to here. I said plt.style.use, that's how you set the style, and put it on dark background. This plt.rc is something you set the parameters. I just gave you one example how to set this font size. Right? Let's say I want to set the font size for my plot to 20. So I say plt.rc set the parameter font size for all the plots that I'm going to plot to 20. Now the rest is very similar to what I did before, right? Define the figure object, fixed size 10 by 5. Plot the XY. XY is still the same sign and function that I had from before. Color green marker, dash line. I didn't change anything. I just copied and pasted the same code. So it's going to plot that up to here. So let me comment out these so we don't get distracted. Somewhere I made a mess. Oh, I think I defined X again. So let me, because I changed the variable Y, right? I rewrote the variable Y with this new function. So to just get back to what I had, I should have named it something else. But now just go back and redefine this cell. Right? Rerun this cell. Now X and Y are these variables. And you can see the background is dark black because I ran the previous cell before. So now for the whole notebook, the background is dark black, dark background, and the font size is 20. You see now these are much bigger, the labels. That was not my purpose to show it on top of that. But here, if I run this one, now you will get a sign function, sign plot 10 by 4. The background is dark background, color is green, same story, and the font is bigger. I could set the font even bigger, and you'll see it, obviously it changes the size that you get for these numbers on these axes. I'm going to activate the second part, or uncomment the second part of the cell. The second part, I said, well, let's plot the same function now using a ggplot style, which is very similar to R from what I know. So I said plt style use, change the background to R style. plt.figure, I set the fixed size, the same thing, and I plotted the same function, exactly the same thing. Now I get the second function, right? The font is the same, I didn't change the font. This style has changed. Right? So you can play around with all these styles and find out which one is what you like. So every time you set a style, that style is set and the font size is set. When you do it with plt.rc or plt style use, it's set for the whole notebook. So if you go back, as you saw, run something again, you'll get the plot with the same style. I put just explanation here. I didn't go to details. If you want to set each font separately for your plots, like it's a general style, you can just use still plt.rc font, control the default text sizes. Then if you want to font size of the axis title, of font size of the X and Y labels specifically, you specifically want to change the font size of the legend, you can use any of these. You can use this instead of plc.rc, or not instead, along with this, you can use that to set font in a specific size. Keep in mind, once you do that, all the plots you get by running your code follow the same thing. Now I use Seaborn, same story, Seaborn white. I use that background or style of plotting. It's not actually a background, it's a style. I define x1 as a function or vector from 0 to 2 pi, divided that to 100 points. y1, I just wanted to show how can you plot two functions in one plot, right? y1 is np sine x1, y2 is np cosine x1. Right? And I defined the figure, same story this time. I don't know why I defined the height as 4 instead of 5. You can change the width too, so now you have a different size figure. And I used plt.plot. Now in this case, I just put all of them in a row. I said, well, plot x1 and y1, use color green, and use dash line. On the same plot, plot x1, which is the same vector, same x, and y2, which is cosine function, right? Plot it. And plot it in color red. R stands for red. you took a look at that table and the list of colors. And make both plots, make the thickness 3. And I was lazy, I just put it in front of it. You can put in the next line, plt.grid. I didn't put b equals to true because once you put plt.grid, if it's off, it turns it on, and if it's on, it turns it off. You want to make sure it's always turning it on, whether or not it's on. Just put b equals to true, like what we did before. So once we have multiple plots, right, if I plot this, right, the style is seaborn white. Right, I have two, one is green dashed line, one is red continuous line. I added the legend here. I use PLT legend. Right, the way it works, the input, a couple of inputs you can give to this. I'm going to make it spaced out so it's more clear. I gave a list of functions I plotted. It goes in the same order you plotted those functions. So the first one was sine, so I named it sine. Again, keep in mind it's a string value, it's a name in quotation. Then the second one was cosine. I put, well, this label for the second one is cosine. If you had more, you could just keep adding labels. And look, which stands for location, I said where the location, put it in the best location possible. You decide where to put it. If I run this, now you see I get a plot that I get my legend here. Right? It says the first one is sine, the second one is cosine. Right, same order that I plotted them. Now there are other options I put there. You can specifically tell the Python, instead of saying the best location, it shows this location lower left because it doesn't interfere with the plots. But you can force it to put it where you want. You can just put it, you can say top right. If I run that, we should have put upper right. Gave me the list of possible options. So if I put upper right, it forces the plotting function to put the legend at top right, upper right. You can change it wherever you want, lower right. Again, best typically put it where there is least interference between the legend and the lines of plotting. Now, one might ask, you might tell me that, so you set the line width to 3 and it plotted both of them with the same thickness, right? If I change it with 5, what happens there? Both of them are gonna be thicker. Okay? You might tell me, what if I want to customize each of them, for instance, line width, separately? I don't want both of them to have the same thickness. Usually it's the case, but let's say there's a case you don't want. Keep in mind, because it still set the X limit, Y limit labels. I didn't do X label, Y label, title, same story. Now, if you want to do that separately, what you would do is, well, just plot the first one, right? And then come here and do it separately. PLT. Now let's say X1 and Y2. And same story. Let's use R. And this one, I want line width to be 2. Still get the same plot. Right? These two are in a row, so it's still going to plot these functions on the same plot. The legend works the same way, but now you have more authority over each specific function. You know, if you want to set things separately, you can do this too. So these are two equivalent to each other. All right, talking about legend. So I just wanted to say we can plot multiple functions in a plot. How here is your assignment. I wanted to write a piece of code to plot an exponential function, np.exponent. Hopefully I'm writing it correctly. It doesn't show up, so yeah, exponent. It does this exponential function, and a tangent function, np.tan. On the same plot, and the range, it doesn't start from 0. It goes from pi over 16 to pi over 3, divided to some number of samples. Use different line type and colors for these two functions. Label both axes. So I didn't do it for the previous one. X plt.x label, plt.y label. And make sure the plot has a legend identifying the functions. Just name them something, put a name so it shows this is exponential function, the other one is tangent function. So subplots, right? The natural next step would be, what if I want to plot multiple plots in a plot? We deal with subplots a lot, at least I personally do. Create the figure, and then just add your subplots. Right? If you say number of rows, number of columns, think about when you add subplots, this defines the object figure. Right? It defines the figure 8 by 4, 8 inches by 4 inches. What the second line does is this line starts, you can start, so you have this object now figure, put this one into figure. Now this is your fig, the whole thing, the object to define. Can be named anything. Now, once you have that object figure with this size, you can start adding subfigures. This case, I said, well, I want a matrix of subfigures, 2 by 3, right? 2 lines, 3 columns, 3 columns, 3 columns, and 2 lines. I want you to divide this whole figure 8 by 4 into 6 subfigures, arranged this way, 2 by 3. And what I'm going to do next, or what I'm going to plot next, this is the first 2 digits. They give the dimension of the matrix. And whatever I plot next, put it on the first plot, 1 here, right? Put it in this. So would be 2, 3, 1. Then once you're done with that plot, you say add subplot. This time you say 2, 3, 2. Whatever I plot after that command, put it in this 2, 3, 2. Go to the next one. Go to the second one, third one, fourth one, fifth one, and sixth one. So you can populate these subplots with the plot that you want. Let's take a look at the example. It might clear that things up a little bit. So I created a vector. As before, I said to start from not 0 because I wanted to use tangent, I think, a logarithmic function. So I didn't want to start from 0. It gives, minus infinity. So start from 0.01, very tiny amount to the right of 0. Go to 2 pi and divide that to 100 points. Define a figure object. It's 10 by 10. It's a square 10 inches by 10 inches. So starting from there, first kind of block I put there, add the subplot, divide this 10 by 10 to 4 plots, 4 subplots, and whatever I plot next, put it in the first subplot. What is that? I say PLT plot x1 and sine x. Red color, dash dot line. Yeah. So and line width 3. And put a label, X label, just I put an X label there to tell you that you can actually config each plot separately the way you were configuring or customizing each plot before. Then the next block or batch of lines, or these 3 lines, I said, well, still that 2 by 2 subplot, go to the second plot. Right? Let me just run this. Maybe it's easier to just talk on the, there you go. Go to the second one. So this is the first one. Right? This is the first batch of line. It plotted this for me. The second one, I said, well, now go to still 2 by 2 grid, go to the second plot and plot cosine x. Right? And keep going. Same story. Go to the third one, plot the log 10. Logarithm function base 10, use color black, and use the marker plus sign. That this is the function. Okay. And the fourth plot, the last one, subplot, right, so 2 by 2 still. The last one, use the color blue and the marker star. I'm not connecting the line, so no line at all, no dash line or even continuous line or anything. So just the series of data points. And plot square, NP square of the values in that vector. Right? So just I put a couple random functions here to show you can plot any function in each specific subplot. And again, each subplot can be set up. You can just put plt.y label for each of them. Again, y values, the same way you were customizing each plot. Right? Now this first one also has a y label. You can do the same thing for all of them. So it starts from the same process. You just, one of the things you need to keep in mind, you're adding subplots using .add subplots. And remember, these two numbers should be the same for all the subplots in the same figure, because the matrix is still the same, 2 by 2. You're just going through this matrix of plots one by one and plot whatever you want. So here is the your practice. Define a figure of size 14 inches by 4 inches. So fig plt.fig, fig size 14 by 4. 3 subplots. I want you to make a matrix of 3 subplots. Right? This time, it's what I want you to create is something like this. And you're going to get 3 subplots. The whole thing is 14 inches this way and 4 inches this way. And I told you what to plot in each of them. The first one, plot a sine function from 0 to 3 pi in the first subplot. I want you to plot the same sine function in all these subplots. The first one, 0 to 3 pi. The second one, I want you to plot that for 0 to pi. And the third one from minus pi to 2 pi. The next natural thing, or at least natural thing to me that I could think of was, well, I have my subplots in a plot. I want to do a little more. I want to adjust, as an example, adjust the spacing between these subplots. I just told you how to plot them, but I didn't tell you what if you want to make these subplots way farther from each other, like or closer to each other. That you can do with subplots that underscore adjust. H space, W space, pretty much the name is kind of obvious. W space is the amount of width for spacing between subplots, and H space is the amount of height reserved for the space between subplots. These are fractions of the width of the plot for W space, and H space is a fraction of the height of the plot. So if I run this code, it's the same code I ran before. Only thing I did at the end, I said, well, now that you plot everything, put everything in that figure, those 4 subplots, I want you to adjust the spacing between these plots. So subplots underscore adjust, H space, W space, both is equal to 1. Meaning that you put space, H space between these 2 rows as the H size or height of one plot. The same story about W space. Make them separated. How much? The same amount of equal to the width of one plot. So if I make them to 0.2, like this, now the spacing would be 0.2 of the width and 0.2 of the height of one plot. This subplot.adjust has other commands, including left, bottom, right, and top. You can take a look at that. Mainly, we care about the spacing between subplots. So that, you can just do it by adding this one line, like subplots adjust. To make things a little, I don't know, confusing or better, giving you more options, instead of defining a plot and then saying that, you know, this is the figure, then figure dot add subplots 2 by 2, 1. You can actually define all those subplots instead of defining a frame, empty frame, and putting subplots or populating that frame with subplots. You can just define all subplots in one shot. And you can use plt.subplots, right? PLT being Matplotlib PyPlot, and use the option or built-in function subplots. Options, right? I said number of rows. So now in this case, I'm defining a matrix of subplots. from the beginning, I'm not creating a figure and then defining subplots. I'm just saying I want from the beginning to define a figure with subplots. 2 rows in this case. I can give the number of rows, number of columns. So 2 rows, 2 columns. This is a 2 by 2 matrix. Figure size for the whole thing, 7 by 7, like 7 inches by 7 inches. And these are 2 last options that are new we didn't have before. I said share X true, share Y true, meaning that the values on X-axis share them between these subplots. And the values on Y-axis also share them in subplots. So as opposed to what I had before in this subplot, you see each axis, this one goes from -1 to 1, the one next to it goes -1 to 1, the one at the bottom, like these two, the ones at the top, they have the same range on Y-axis, but the labeling or the axes have different, have separate labels, or not, better to say they're not labels. They represent the range separately. Now what I can do with that share Y is I can just get rid of this and attach these two together, and I say, well, this is the Y for both. So make my graph or plot a little less crowded. If I run this, I did a little bit of fancy thing here that I use 2 for loops, right? So keep in mind when you use subplots this way to define subplots, you get 2 outputs. One is the figure, one is axes. Axes are the axes for each figure, right? So in this case, you're going to get an axis, an object, and that axis is a 2-dimensional array. That axis, for instance, if I go back to what I had from before, if I define it, this is axis 0, 0. This is axis 0, 1. This is axis 1 and 1. And this is axis 1 and, 0 and 1 and 1 and 1. It's an array. Instead of getting just one fig output, I get 2 outputs. One 2-dimensional array for the axes of each subplot and 1 figure. Now I can use that axis here. I again did it a little bit fancy here. I said, well, go over these 2 axes, like 0, 0, 0, 1, go over to each subplot. 0, 0, 0, 1. This should be axis 1, 0, right? I don't know what did I say before, but it should be 1, 0. 1, 0, and then 1, 1. Go over these axes. And what I did in this for loop is that I said, well, go over these axes, just plot the same function. You could plot them separately, right? Any function you wanted. I just wanted to make this short. And then adjusted the spacing. If I run this, now I have 4 subplots. They're sharing the Y-axis and they're sharing the X-axis. So I don't, because the range is the same for all of them, I used share X and share Y, put it true. Meaning that now I don't have 0, 2, 4, 6 here and 0, 2, 4, 6 here. I just, this is enough for both of them. The same story about the Y-axis. I don't have -1 to 1 here and then -1 to 1 here. Because they share the same set of ranges, they have the same range, I just directly said, you know what, just share these between these subplots. So make it more compact. Whether you want to use define subplots this way or not is up to you. Right? Again, this for loop, what it does is that pretty much I could just write, I could just say axes, right, 0 and 0, which I might be able to even overwrite that. Like here, let's say axis 0 and 0 dot plot, and instead of x1 and sine, I can use np cosine. Might not be a good idea since I'm sharing the x and y values, but let's see what it gives us. I'm curious. So now I just added, I had those 4. Now I said, well, add to this specific axis cosine function. I could add that cosine function to the next one, right, 0, 1, and get it on the second one. So you can always refer to each axis and add more plots. I wrote it in a for loop. We can just do it one by one. Axis 0, 0 dot plot this function. Axis 0, 1. The same story as before, but what changes is that I just define figure and axes all at the same time. I define number of rows and columns. I gave you a class assignment here, pretty much very similar to what you did for subplots. I wanted you to create a subplot of 2 plots, so the matrix is 1 row, 2 columns, and plot the natural log. Natural log is being np.log, so it's no log 10. In the first subplot, and hyperbolic function, tan h, right? np.tan h in the second subplot. And I gave you the range. The last thing I want to talk about is saving. Right? So you created your plot, you have it nice in notebook, but you want the file. You want to put it in some report, you want to put it in your presentation. How do you save it? That's where plt.savefig comes into play, that command, right? That function. Now it has a couple of options. The way it works is that you basically put plt.savefig. Options are figure name, obviously. Right? When you put the figure name, you can identify the name with its extension. Right? You can save it as a PDF file, you can save it as a PNG file, or we can just use the name and identify the extension later on when you talk about format. Right? So you can either save it as figure1.png in quotation when you refer to name, or you can just say, well, I'm just going to save it as figure1, and later on for the format you put PNG. Well, you can get different formats, whatever format you want as output: PNG, PDF, vector form, SVG, EPS, more like Photoshop or other graphic softwares, like more quality figures. And you can define, these are the important options. The other ones, you can define the quality, dots per inch. Higher this number is, the more the quality. Default is 100, you can put it on 300, 400, you get the high quality picture or figure. And eventually I use bbox inches, the option tight. What happens is if you use option tight and you have something like this, your plot is there, what Python does, it usually is generous with the amount of spacing it gives between the plot and whatever it's going to save. So you might get something like this when you save it, but you might not want this extra space around. So you activate bbox inches tight, so it attempts to trim any empty space around, so you only get, you don't get this extra space, you get just the plot itself. I typically keep it activated. Now, the last note I put here is that that's good enough, right? I put an example here. So if you were on your own computer running this, right, I put this style as seaborn white as before. You've seen how to set the style. I just chose this. I define linear space. I put 2 functions, very similar to plotting 2 functions, same block of code I brought here. Define sine and cosine. I define the figure, 10 by 4 dimension. I plot both of them on the same plot. Right? And then I said, well, I want to put the legend. Right? I have 2 functions, sine and cosine. I put the legend, put it in the best spot possible. That's not what I wanted to do. And then I said PLT savefig. So how did I do this savefig? Well, I put the name of the figure. I didn't use format. I just said .png. So Python is going to figure out it has to save it as PNG. It's typically what I do instead of putting the name and then defining the format. I put DPI, quality of this figure, dots per inch, 200. And I made it a tight box so I don't get extra space. Face color, if you go back, I typically don't use it. I just put it here so you can see it's like the color of the figure background outside of this. If you have a set of subplots, right? Even if you get a very tight frame, you still are going to have a spacing between those plots. So you want the color for that spacing between those plots to be white or just be some default color, whatever it is. I put it W as white, face color as white. You could just erase it and let it be the same color. If I run this, since I'm running this on Google Colab, Nothing happens, right? Now, there is an extra step you have to take when you are using a cloud notebook on cloud. If you're on a computer, this is good enough. This save figure is going to save this figure, save figure.png under this name, save this plot under this name on the same directory that your code is. But on the cloud, you have to add these two lines. You have to import this library I specifically mentioned here. From Google Colab, you have to import files. Remember, we're dealing with a cloud system. So the file is saved on the cloud. I want to download it. So what you do is that you import files function or module from Google Colab and then download the file you just saved. These two names should be the same. You just save this in memory. Now you want to download it. You say files.download, the same figure I saved. If I run this, now it's saved, right? And now it gives me this pop-up window. It says, okay, now you can save it. Right? Same figure, save figure.png. And if I open this, there you go. You get the figure that you generated, right, in PNG format. Change the format, change the quality, it's up to you. Last assignment, right? Use 538 style. And I want you to plot three functions, y1, y2, y3. Remember, you plotted one function before using a polynomial. The range from -5 to 5. Use different line style for each plot. These are not subplots. All of them should be in the same plot. Make labels for axes, whatever label you want to choose. Time versus value, amplitude, whatever. Put a legend for each of them, name them, y1, y2, y3, whatever you want to name them. Turn the grid on and save and download the figure.